Hello everybody, I welcome you all to NK's Geology class. Today I will discuss about the topic sampling. Let us know what is sampling. Sampling is a process of collecting a small representative portion of a material that may be rock, soil, ore, sediment or water, so that the properties of the same sample reflect the whole from where it has been derived. A sample is a small amount of material, some small representative portion of the material that represents the whole from where it has been derived. Small portion, small amount that represents the whole deposit from where it has been derived. So, there lies the difference between sample and specimen. Specimen is the representative of itself only, whereas sample is the representative of itself. In addition to it, it represents the ore body or mineral body from where it has been derived. So, specimen, it represents itself with respect to its quality and quantity, whereas sample represents the ore body from where it has been derived with respect to quality and quantity. Sample is the representative of itself. Similarly, specimen is the representative of itself. But when specimen is the representative of itself only and it does not speak anything beyond what it contains, it does not tell anything beyond what it contains, whereas the sample speaks about the quality, quantity of the deposit from where it has been derived. So, what are the purposes for which samples are being collected? Sampling is a process of collecting samples to represent the whole. So, what is the purpose? So, these are the purposes: to estimate the reserve of the ore or mineral deposit, to determine the grade of the ore, to know about the different types of minerals and ores that are available in an area of investigation, to know about the length, the width, depth wise variation of the rock, variation of the ore, and thus on reserve estimation. So, ore is collected to determine the reserve. What is lengthwise distribution, widthwise distribution, depthwise distribution? So, what is the total reserve available? That in a mine, that is being considered, that is being decided, that is being found out from the samples. For evaluation of mine's cost, to know about the suitability of the ore materials for beneficiation processes, whether the beneficiation process can be adapted over the collected materials or not, so that the grade can be upgraded, grade of the ore can be upgraded. So, that thing can be decided by study of the samples. For the sale of the mines, for preparing the inventory of the mineral deposits, what are the deposits that are available in a country. So, these are the purposes for which the samples are being collected, samples are being analyzed, samples are being used to determine the quality, quantity of the deposit. Samples are used for the valuation of mine, for sale of mine, for knowing the mineral deposits, whether they are suitable to take beneficiation methods, to upgrade the quality of the ore or not. So these are the different processes. These are the different purposes. So while samples are being collected, care should be taken so that the samples are not being affected by interference of the interested parties, because the samples are collected with some purpose, but that purpose will be defeated if samples are not properly kept under the custody of the trust or the person entrusted with the task of going for sampling. So there are different cares which the sampler should take. The samples collected from different sites are perfectly labeled, numbered, location and depth noted, and weight of the samples are noted over the sample containing bags. So samples are generally kept in bags. So the bags should be numbered, bags should be labeled with respect to the location, depth from where the sample has been collected, so that the reserve estimation will be possible. The samples collected are kept systematically under the custody of the trust or the person, so that nobody can tamper the quality and type of the sample collected. Otherwise, the purpose for the sampling done will be defeated. The sampler doing sampling should take into account the mode of occurrence of the mineral deposit, their variability in 3 dimensions, length, breadth, thickness, and accordingly should plan to collect the samples so that minimum number of samples are collected and the purpose is not defeated. Samples should not be collected from the weathered outcrops. Samples should be collected parallel to the true width of the ore body. Planning is to be made for collection of minimum number of samples without sacrificing the purpose for which sampling is done. In case of borehole sampling, the cost of going for borehole drilling is high. So, with judgment, boreholes are to be drilled to get optimum results. So, these are the cares that should be taken by the sampler so that the cost is being saved and the purpose for which sampling is done, that is not being defeated. And the instruments which are being used for sampling are the hammer, chisel, spade, shovel, mechanized loaders, GPS, XRF, camera. So they are the equipments which are used during sampling process. And now let us discuss what are the different types of sampling. These are graph sampling, chip sampling, group sampling, mock sampling, stack sampling, alluvial placer sampling, borehole sampling, sludge sampling, reverse circulation drill sampling, bulk sampling, car and wagon sampling, ocean bed sampling. So let us discuss these sampling methods. Graph sampling. This sampling is done, or this is the process in which samples are collected at random from the exposed outcrops, pits, trenches, stacked materials, mine workings, mine cars, load shipments, and from all types of stockpiles. Simply, the samples are grabbed from exposed surfaces, exposed stacked materials, and these samples are not used for reserve estimation because they are collected from stacks, they are collected from pits, trenches, and they are collected at random without keeping in mind that it is going to be used for reserve estimation. However, these samples provide an information about the different types of ore deposits ore materials are that are available in an area of investigation. That speaks what are the different types of materials that are available in the area of investigation. So these are the graph samples. Simply the samples are collected without having any definite aim. Here and there they are being collected or they are collected at random. Cheap sample. Here this is adapted in case of the minerals which are found to be very irregular or which are found to be in form of disseminations, as is seen in case of gold deposits. Gold occurs as veins in form of disseminations. So here the fragments are chips or samples having 1 to 2 centimeter by 1 to 2 centimeter sizes, covering the entire surface area or exposure underground mine faces, walls, roofs, are collected in a regular interval of 25 centimeter by 25 centimeter. So in this small area, chips of this size they are collected, and the area is cleaned before cutting sample. Then the chips are being collected in a clean box or satchel or canvas sheet. The weight of the sample is generally 1 to 2 kg from 3 meter to 3 meter area. This is the area, the amount sample about 1 to 2 kg, and this type of sampling involves low cost. It helps quick evaluation of grade of the ore and is a faster process of identifying mineralized contacts, because at regular interval it is being collected, and this is the area 25 centimeter by 25 centimeter area. Mineral chips are being collected, or chips are being collected. So it gives a quick evaluation of the grade of the ore, and it is adapted when the ore deposits are found to be in disseminated form. Channel sampling. Here, channel or groove is made over the ore body, and then the groove is deepened to collect the sample, because the ore surfaces are generally found to be weathered. So first the surface is cleaned by making a groove or channel, then the channel is made deep to collect the sample, and the grooves are made, or these channels are being made through the trenches, pits, underground mines, that is drifts, winches, ridges, shafts and stopes. So these are the mining terms: drifts, winches, ridges, shafts, stopes. These are the mining terms. Let us have a picture over these terms. Let us say this is a ore deposit, underground ore deposit. This is another ore deposit, vein deposit. And these vertical underground passages, these are called shafts, vertical shaft. This is an inclined shaft, this is inclined shaft. These shafts are made to reach at the ore body. So this is the shaft, vertical shaft. These are the cross cuts. These are the cross cuts to link the passage up to the ore body. And if it is done downwards, the ore body is drawn downwards from the cross cuts. This is winch. If it is raised upwards like this is ridges. This is winch, which is the passage in the ore body downwards. Ridge is the passage in the ore body upwards in order to collect the ore material. So these are the cross cuts to reach at the ore body. And within the ore body some space is being created for the ore collection, ore accumulation, that becomes the stope. And the rock body above the ore body is called the hanging wall. The rock body below the ore vein is called the footwall. If the opening is from one side and it is reaching the ore body, open at one end, blind at the upper end, the other end, it is called adit. So these are the vertical inclined passages, which are the shafts to reach at the ore body. Cross cuts, they link the shafts to the ore body. Hanging wall, the country rock lying above the ore body. Adit, it is a level drive or tunnel from the hillside up to the ore body. It opens to the surface at one end only, but the normal tunnel opens at both ends. Drive or drift, the horizontal tunnels parallel to strike up the load, strike up the ore deposit, strike up the vein, and they can be located on the country rock, either on the footwall side or on the hanging wall side. Accordingly, they are being named footwall drive or hanging wall drive. Level or the hanging wall drive is a tunnel in the ore body or vein which follow the strike. In case of coal mining, it is called as gallery, the horizontal passages parallel to the strike of the ore body. Raise from the level, excavation is made in the ore body upwards, it is raise, downwards it is winch. This is winch, this is raise. Stope, it is underground excavation made to remove ore or for winning ore. Underground excavation where the material collected may be stored, and from there it is being owned, it is being derived. And this is the adit. Open at one end, the other end is closed. So these are the terms, mining terms, which are being used to recover ore. So shafts, cross cuts, hanging walls, footwalls, drives, adit, winch, raise. So these are the terms. Stope, these are the terms which are used in mining. And in case of channel or groove sample, the groove is being cut, groove is made in order to ensure uniform quantity of material to be drawn over the entire width of the ore body. For that, the grooves are being drawn. As the ore outcrops present irregular surfaces with weathered zones, grooves are cut to expose planar and fresh surface of the ore body for sampling. Normally, the channel is cut with width of 10 cm and deep 2.5 cm. This is a channel. 10 cm width, 2.5 cm deep. After that, the groove is further made deep to collect the broken material at the sample. The amount of sample is generally of the order of 1 kg for 30 cm groove length. channel is mostly driven parallel to true width. If this is the dipping body, this is the true width. If this is the body, in this manner the trench is being done, so that by deepening the groove, the material may be collected parallel to true width. Because if the material is collected parallel to true width, it can be a representative sample. This is the horizontal groove, this is the true width. If it is not easy to collect the material parallel to true width, then we can go for horizontal collection of the sample. Generally, care should be taken that samples are collected parallel to true width, it will be a representative sample. Then let us discuss what is mock sample. Here, the samples are collected through a few handheld spades. This is the handheld spade, or by mechanized shovels from mine face or from stove, where the materials are being stored. Stove draw points and are used to compare with the drill estimates. These samples are compared with the drilled samples, drilled materials. Whether drilled material and the samples they match or there is any variation. So average production of grade over a period of time, such as 1 week or a fortnight or a month or a year, is compared with the drilled data. These mock samples are collected for this comparison, for comparing the production over a period of time. They are collected through few handheld spades or mechanized shovels from mine space or from stove draw points. This is stove draw point. So by shovel, these materials are the broken ore, they are collected, mock sample. So it is just to have a comparative study of the monthly production or weekly production or the yearly production. These samples are used for that purpose. Now let us discuss what is stack sampling. It is the collection of representative broken material generated by pitting, trenching or by any mine production. Here the samples are collected by inserting a 10 to 40 centimeter diameter cylinder down to the base of the stack, because in mine sites we find that the materials are being stacked at different points, and from those stacked materials the samples are collected, and the samples are collected in this manner. They are from a central pit, they collect sample from 4 sides, there the samples are collected and they are mixed. A composite sample is being prepared, and that sample is subject to coning and quartering to get the representative sample, and this is the case when we collect the samples from the stacked material. So this sample is not useful to know the reserve, and through this stacked sampling, the information about the type of materials that are already been recovered. About that, the information is known from these samples. Then let us discuss what is alluvial pressure sampling. Alluvial pressures, in case of rivers, the mineral matters are found to be deposited along the meanders, along the river meanders. So, the samples from the river meanders are collected, or the rivers which feed the mineral matters to the oceans. Those ocean beach materials are being studied. So rivers, they provide the mineral matter to the oceans, and the beach become the site for accumulation of such riverborne deposits, as it is found in case of the beach sands of Gopalpur area of Odisha. So these samples, the pressure deposits along the river or along the sea coast, the valuable minerals, they are being sampled by scooping through hand shovel, hand spade, or by auger drills. As these samples are loose sand or wet or dry sand, they are collected in grid pattern up to certain depth. Generally, a casing is driven into the deposit to protect the wall collapse and to avoid contamination during the sample collection. So, in this manner, the samples, alluvial samples are being collected. For example, these beach pressures of Gopalpur coast in Odisha, where the rare earth elements are collected. Rare earth minerals are being collected. So that can be possible through alluvial pressure sampling, because in this case the rivers, particularly in Gopalpur coast of Odisha, the two rivers which contribute the heavy sands from the external group of rocks, they are the river Rushikula and the river Bahuda. They contribute the heavies to the beach of Gopalpur. So beach samples are being mined by Indian Rare Earths Limited, IRE Limited. This company is mining the heavy minerals from the beach of Gopalpur coast. So this type of sampling is called alluvial pressure sampling. Besides these, we have other types of sampling also. These are borehole sampling. In case of borehole sampling, the samples are collected from underground in order to have a picture about the mineralization that has taken place underground. Here the cores recovered by drilling is used as one sample. This borehole sample is suitably, therefore the boreholes are suitably placed and spaced, keeping in mind the mode of occurrence of the ore body. And the recovered solid core is split into two parts by core splitter. One half is kept for visual examination, the other half is subjected to coarse crushing, grinding, coning and quartering to get the representative sample. So in this manner, the borehole samples are being used for analysis and for comparative study. Besides that, we have the sludge sampling. During borer drilling, finer co-product particles of diamond drilling are generated, and these coatings of rocks between the core and the outer hole diameter, they form the sludge material. Where the core recovery is not high, poor core recovery, in that case these broken sludge materials, they will have to be taken together along with the core recovery in order to find out the total mineralized zone. Because during the drilling process, the main mineralized zone may be lost during cutting of the core as sludge material, and the recovery of material through the core sample may be very low. So, the recovered core material along with sludge are together considered in order to have a clear picture of the underground mineralization. That's why the sludge material should be taken into account along with the recovered core. And it depends upon the operation, upon the operator, that how is going to incorporate the sludge material along with the recovered core in order to make the sample. And these samples show the existence and to some extent the quality of mineralization in absence of good core recovery. But the good recovery of core is not there because of the fractured ore minerals at the subsurface. In that case, the poor core recovery is mixed with the sludge material to make a total sample, so that the quality of the mineralization can be correctly evaluated. So this is a case when we talk about the poor core recovery. So sludge materials are being taken into account along with the recovered core to make a total sample. Beside this, there are reverse circulation drill sampling. In this case, there is collection of rock cuttings with respect to drill depth. The entire rock cuttings are raised to the surface by return air pressure and collected in glass chambers in an inverted sequence of depth, forming a sample. During the drilling process, the sludge materials, or during the coring process, the broken rock matter are brought to the surface by reverse circulation or by air pressure. As the drilling continues, the broken rock matters are brought up and they are collected in a glass chamber. So, the first material that will be deposited in the glass chamber will be near the surface, then to the deeper depth, then to the deeper depth, then to the deeper depth. So, in this manner, the materials are collected in the glass chamber. So, it shows from top to bottom in reverse sequence, inverted sequence. The materials are collected in inverted sequence of depth, forming a sample. This is reverse circulation drill sample. These samples are not an exclusive and ultimate solution to the mineral deposit evaluation. So during drilling, this is possible. So this sample should be equated with the core sample. They are mostly used in grade control of the mine production in advance and particularly for large open pit mines. So the recovered core along with these reverse circulation samples, they are together taken into account to know the quality of the material, to know about the grade control of mine production. For this purpose, the reverse circulation drill samples are being used. Besides it, we have the bulk samples. Bulk samples are collected in terms of tons. They represent the metal grades of and mineral distributions in an entire ore body. The samples are collected from different parts of the stockpiles or from surface trial pits, from underground crush cuts, run-off mines, and the instrument used is the shovels to handle huge volumes. What is the purpose of this sampling? These samples are used for developing beneficiation process for optimum reagent consumption and maximizing recovery efficiency. So bulk samples are collected in order to know whether the samples are suitable to take up beneficiation methods so that their quality is upgraded, or whether the samples will be suitable for certain use of reagents in order to maximize the recovery efficiency or not. That is being studied. So samples are collected in bulk samples. Similarly, car or wagon sample, it is a type of bulk sample. Car samples are collected in underground condition and wagon samples are collected in surface condition. And these samples are also used for study of the suitability of beneficiation methods to be adopted for upgrading the quality of the ore. Generally, what is seen that in the iron ores, the bulk samples are collected to examine the ratio of fines below 12 mm to the whole mass of the ore to be mined. Because it is known that the fines, they cannot be used as such in the blast furnaces for metal extraction. The fines require agglomeration. It is a type of beneficiation process. So, how much fines are there in a huge sample? That is being studied by collecting bulk samples or car or wagon samples. So, samples in bulk are collected to see the suitability for beneficiation. Similarly, in case of coal, the bulk samples are collected to study their washability, whether they can be washed or not, what will be the byproduct. That is being studied for coal. So, these are the major bulk samples, that is car or wagon sample. Similarly, we have the bulk sample. And besides this, we have the other types of sample that I have already discussed, that is reverse circulation sample, then the sludge sample, Border sample, alluvial placer sample, it is a type of bulk sample. Then we have the stack sample, muck sample, channel sample, chip sample and graph sample. And finally, let me discuss about the ocean bed sample, which is adapted for ocean floor deposits. Now let us discuss what is ocean bed sampling. This method is adapted in order to sample the nodules from the ocean floor or to sample the metallic sulfides which are found in the ocean floor contributed by the hydrothermal vents. Because hydrothermal vents, they through white smokers and black smokers produce the sulfide minerals, and these sulfide minerals are being deposited in the ocean floor. So by ocean floor sampling, these manganese nodules or different types of metallic nodules or the metallic sulfides, the samples, the materials are collected, analyzed to study the richness of the ocean floors with regard to the occurrence of these metallic minerals such as manganese, nickel, copper, cobalt, their nodules, and the minerals, sulfide minerals of copper, zinc, lead, gold, silver. So how they are distributed at the ocean floor, that are being studied by collection of the samples. The samples collected from the prospective areas of the ocean floor is conducted by progressive reduction in sample grids through 100 km by 100 km, 50 km by 50 km. In this manner, the area is being reduced to 12.5 km by 12.5 km or square kilometers. The collection unit is designed as a bucket in pipe nodule lifting system. In this manner, the nodules are being lifted from the ocean floor and they are tested successively. The quantity of the material collected in the trip is about 110 tons, and that material is gradually reduced to 200 to 500 kg. In this manner, the ocean floors are being sampled in order to know whether the ocean floor is containing rich occurrence of the sulfide deposits or not. When the ground materials will be exhausted, then sea surfaces will be explored to provide these metallic sulfides. So this is all about the sampling. Sampling is followed by assaying. Assaying is followed by reserve estimation. So sampling is a very important matter in the process of reserve estimation of the ores or minerals. Therefore, the sampler who is interested with sampling should take all cares that samples are collected in a systematic manner and they are properly used to give information about the deposit. So samples collected are analyzed, systematically taken into account, and their asset values are used to find out the reserve. The main purpose of sampling is to find out the reserve. So, the sampler has the main duty to see that samples are collected in a systematic manner and the samples are being analyzed systematically, assessed systematically, and the results are gradually incorporated in order to find out the reserve. So this is all about sampling. Next I will discuss about assaying and reserve estimation. Thank you all for giving a patient hearing to my present talk.